Alright, good afternoon everyone. We are going to look at chapter 6 in this clip. Okay, and this chapter 6 is about discounted cash flow valuation. I prefer to call this advanced time value of money methods. Advanced time value of money. So we have seen time value of money, the basics, in chapter 5. In chapter 6 we are going to look at more advanced techniques or advanced issues, advanced matters. Okay, I'll skip this outline. I'm going to show you a different outline here, the key topics that we are going to look at in this chapter. There will be 5 key topics. The first one is value of multiple cash flows. Okay, that's the first topic. Okay, previously we have seen only a single cash flow in chapter 5. But in this chapter, we are going to modify that and we are going to look at multiple cash flows. And we want to determine the value of these multiple cash flows. Right, then the second key topic is about annuities. Okay, so we will look at what is annuity. Then we will look at the present and future value of annuity. How to determine the value of annuities. Here we determine the value of multiple cash flows. Here we look at the value of annuities. And also once we know about annuities and we can determine the present value or the future value of annuity, then we look at the other aspects of annuities in this topic. Then the third topic, we'll look at other types of annuities. We'll look at annuity due, okay, then perpetuity, then growing annuity and growing perpetuity. So there are 4 types here. The annuity that we're going to look in the second key topic will be called ordinary annuities. So here we have other types of annuities. Annuity due, then we have perpetuity, growing perpetuity and growing annuities. Growing perpetuities. So we look at all these in topic number 3. Then in number 4, we look at compounding frequency. When we change the compounding frequency, so what happens? So the assumption here is we compound only the original assumption for the first 3 key topics. The assumption is that we compound only once a year. Okay, that means compound here means you add interest to the principal. So you add interest to the principal only once a year. Okay, but in this 4th key topic, we relax this assumption. That means compounding can be more frequent than once a year. Okay, so this complication will lead to other things like period rates. So we need to know what is period rate, what is APR, okay, and what is EAR. These are all rates, interest rates, and what is continuous compounding. All these are related to compounding frequency. So we'll look at that in key topic number 4. And number 5, the last part, the last key topic, we'll look at loans, different types of loans, which is an application of time value of money. Okay, we look at pure discount loan, interest only loan, and amortized loan. And amortized loan, there are 2 types of loan. Amortized loan, which is called fixed principal payment loan and fixed payment loan. This is a bit more popular than this, but we look at these 2 together. Okay, so this as an outline, this is what we're going to look at in chapter 6. Alright, let's continue. So we look into the first key topic, which is the value of multiple cash flows. Right, when we say multiple cash flows, here we look at future value first. This is the first example. We start with an example. We solve the example and then we learn about this problem. Let's look at this problem first. You think you will be able to deposit 4,000 at the end of each of the next 3 years. In a bank account paying 8% interest. You currently have 7,000 in the account. So the first question, we ignore the second question here. We look at the first question. How much will you have in 3 years? Alright, so we look at the features. Remember the key components in a time value of money problem. Okay, so we look for the key components here. The first component will be this, what is this 7,000? 7,000 is what we have considered as present value in the previous topic. Present value. In chapter 5 we call this the present value. This is the cash flow at time 0, because you currently have, that means at time 0 now you will have 7,000. So that's the first component. The second component is this interest rate. Now 8% interest rate means the account pays 8% interest compounded per year, every year. So 8% must be written here, right? And then you know the term, here, because the term is defined by this, how much will you have in 3 years? Okay, but the complication here, 3 is the term, Alright, so we know 3 things, we know the cash flow, okay, which is the present value. Then we know the interest, R, and we know the term, number of periods, 3 years. Alright, but in this problem we have an additional component, because it says you will be able to deposit $4,000 at the end of each of the next 3 years. That means here you will have 4,000, you deposit 4,000 in year 1, year 2 you deposit another 4,000, and year 3 you deposit another 4,000. So this stream of cash flow, this is called multiple cash flow. You have more than one. You don't only have 7,000 here, but you also have 4,000 here, another 4,000 here, and another 4,000 here. So we can show that here. Note that this negative 4,000 means you deposit, you forego, you don't use the 4,000, therefore it's a cash outflow. You deposit into the account, but from your perspective it's a cash outflow. From the perspective of the account, this will be a cash inflow, of course, Alright, apart from that, you have also the interest given here, 8%. So this is what we mean by the multiple cash flow. You also deposit 7,000, and this is what you have, but you forego this. You put this into your account. Right? If you withdraw this, then this becomes positive. But because you currently have this, and you continue to deposit this in the account, so this will also be negative. All these are negative cash flows, and this is the term. So that's the difference. In chapter 5, we had the interest rate, we have the cash flow, and we have the term. And we can solve for the future value of this cash flow. But here you don't only have one cash flow, you have multiple cash flows. So how do you determine the future value at year 3? So that's the problem that you're facing. So how do you solve this problem? So first, this is the best method, the future value of multiple cash flows rather than a single cash flow. There's a difference between this chapter and the previous chapter. Alright, so we want to know what is this future value. So what we do, we can follow the method that we have learned in chapter 5, which is to compound each of this cash flow, sum or cash flow, separately. This you take the future value at time 3, this you take the future value at time 3, this you take the future value at time 3, and this is already at future value time 3. Alright, therefore you just add all 3, then you get the future value at year 3. So that's what we are going to do next. So the next question, how much will you have in 4 years? So once you've got this future value here, then we can compound this another year. You compound for 1 more year, you get the future value for the 4th year. So that's the method that we're going to use. Alright, so in this next slide it tells you the solution. It says now you have $7,000 that you have deposited, you have in the account already. So this is compounded 3 years, 3 times. Compounded 3 times, meaning interest is added to the principal 3 times, because it is over 3 years. Therefore you take the present value, present value multiplied by 1 plus r raised to the power of n. So n is 3, r is 8%. Therefore this is the value of the cash flow. So how do you interpret this? $8,817.98 is the future value of this $7,000 now after 3 years at 8% interest rate. Yeah. All right. Then the next cash flow is 4,000. Yeah? This is the cash flow that occurs at year 1. You take this to future value. Yeah? So you take present value here, 4,000, multiplied by 1 plus R raised to the power of 2. Yeah? Because this is compounded only two times, yeah? Or 2 years. Okay, once a year, therefore there is only 2 years left. Yeah? Because this is the cash flow at year 1. This is compounded to the second year and then the third year. So this is the value. Yeah? So this 4,000 is actually worth $4,665.60 at the end of year 3. This 7,000 is worth $8,817.98 at the end of year 3. Yeah? And then this cash flow, okay, 4,000 that you deposit at the end of the second year, you compound this. Yeah? You compound this for one year. You multiply with 1 plus 8%, so this will be the value, yeah, 4,320. It means that this 4,000 that you deposit at end of year 2 will be worth 4,320 at the end of year 3. Yeah? And then the year 3 cash flow, which is 4,000, this you don't compound because it's already at the end of year 3. Yeah? So therefore, now all these cash flows are at the same time. Yeah? Notice this is in year 3, end of year 3. This is also end of year 3. This is also end of year 3. Yeah? And this is also end of year 3. Therefore, you can add these cash flows. Yeah? You cannot add cash flows if they are at different years. Yeah? They are all in the same year value. Yeah? Alright, total value in 3 years will be this plus this plus this and plus this. Yeah? Therefore, you get $21,803.58. Yeah? So that's the answer. Now the value at year 4, what do? You take this value, right? Then you compound for another year at 8%. Yeah? Because this is the sum that you will have at the end of year 3. So you want the value for year 4. This is your total savings, yeah, in the account. Now this you would compound for another year from year 3 to year 4. So this $21,803.58 you multiply with 1 plus 8%. You compound only for 1 year, yeah? From year 3 to year 4, 1 year. Yeah? Therefore, the value is $23,547.87. Yeah? There should be a dollar sign here. Yeah? The dollar sign is not being shown. Yeah? So that's the answer. That's how you solve that. Yeah? Now, the important thing to note here is this. Yeah? You can only add cash flows that are at the same time value. You add this, okay, because all these cash flows now are at the same time value, meaning they are all in year 3. You cannot add 7,000 with 4,000 here, and this 4,000 with this 4,000, and this 4,000 with this 4,000, because they are all at different times. Yeah? So this is an important principle to hold on to. Yeah? You cannot add 4,000, this 4,000 with this 7,000, because this 7,000 is the value at time 0. This 4,000 is the value at time 1, yeah? End of year 1. Okay, so you cannot add them across, but you can add here these two, yeah? Because they are all at the same time value. Is that clear? Alright, yeah? So we move on. Okay, so this is an important principle, yeah? So you need to remember, yeah? Students, please remember this principle. Yeah? This is very important. Alright, now I'm going to show this example in a spreadsheet. Yeah? For that, we'll go to the spreadsheet.